The materials that you will need for this activity are 4 very large white buckets, 3/4 full with fresh water, a plastic container with gravel or sand, mud, flour, and materials to make a sechi disc. This includes a plastic lid, white plastic plate, or a frisbee, a hole punch, which can be used with a hammer and screwdriver, 5 feet of thick cord or rope, metal washers for weight, a ruler, thick black permanent markers, and black tape. Seagrasses have been able to successfully grow in the marine environment because of many properties. These include the ability to live in a salty environment, growth when fully submerged, clear water for good light, a well-developed anchoring system, the ability to complete their reproductive cycle or pollination underwater, and water temperature influences the rate of growth and the health of seagrass. Seagrasses need nutrients to grow, which are often obtained from nearby mangroves. They also require light, therefore thriving in clear water. They flourish in shallow, protected coastal waters where there is shelter, such as a sandbar, from drying winds, from wave action, and strong currents which could create turbulent muddy water. They cannot grow easily where a low tide will expose the plant and dry it out. So, seagrasses need light to produce food through photosynthesis. The light that the seagrasses receive must penetrate the water column in order for it to be efficient. There are many things that can prevent the seagrass from receiving light. Suspended sediments and chemicals are 2 of the major restrictors. The first part of the project is to make a sechi disc which helps to determine the visibility level of the water. First, punch a hole in the middle of the plastic lid or alternative. The color of the sechi disc will be split up into alternating black and white sections. Use a black permanent marker or black acrylic paint to color in the black portion of the disc. Tie a knot at one end of about 5 feet of rope and place string through the hole. Attach some weights to the bottom of the disc so it easily sinks to the bottom of the bucket. Metal washers work well for this purpose. You may wish to mark the rope every centimeter for ease of taking measurements. Your new homemade sechi disc is ready for use. Having filled each of your buckets 3/4 full with clean water, you are now ready to measure the impact that different levels of turbidity have on light penetration. Lower the sechi disc into the first bucket to show students that they can see to the bottom. Take the sechi disc out, then add the mud to the bucket. Observe the bucket and lower the sechi disc into the bucket until you can no longer distinguish the black from the white. Measure how deep the sechi disc was lowered. Record the depth and any other observations. Repeat this process for the next 2 or 3 buckets, adding different ingredients to each bucket. Then discuss the results with your class. Ask them what the difference was between the different ingredients that were added. Ask how the different ingredients affected the amount of light at the bottom. Make connections between the ingredients used and the real restrictors in a seagrass habitat.